Well, hi, everybody. We're going to talk about a few planning and scheduling topics today, mainly in the realm of planning. There's quite a bit that we could say about the subject, obviously, and so for our purposes today, we're going to focus on a few things in particular. To begin with, I think it's important to make sure that everybody in your organization who is connected with the planning and scheduling processes, and this includes maintenance supervisors and maintenance managers and reliability engineers, as well as production supervisors and production management teams and people in the storeroom, et cetera. There's so many people that impact planning and scheduling, and everyone is very important that everybody is very much aware of the key reasons why a company should be pursuing improvements in planning and scheduling and why is a core business practice. The three reasons are listed on this first slide here, and real briefly, the first one is standard work. This is a key thing for anybody that's had experience in Lean Six Sigma or improvement. You know that variation is the enemy. And in planning and scheduling maintenance work, if the maintenance tasks that are being done, whether they're PM tasks or corrective maintenance tasks, if there is a wide variation in the way that the employees go about doing these business practices, because the procedures are not very well defined in the CMMS system, what this means is that all the employees are going about all of their maintenance and reliability functions in non-standard ways, and variation starts to flourish. And it is so easy for failure modes to be inflicted upon a piece of equipment when we go in to try to do a maintenance task, because the QA specs are not specified in the work orders. So standard work and getting everybody to do things in accordance with best practices in terms of the PMs and the corrective maintenance work and the inspections, that sort of thing, that is a critical, fundamental business practice right there. But the second one is to make improvements in reliability. You cannot really achieve the goals that you're trying to achieve when it comes to reliability unless you're good at planning and scheduling, because otherwise so many man hours will be wasted and lost due to ineffective and inefficient practices, and you won't have time to make the improvements, because all these improvement processes, RCM and TPM, these kind of things, they require a high number of meetings and alignment sessions, and they require a lot of training and coaching, and you got to make time for that. And how can you get that time is by being good at planning and scheduling. The third thing on this slide is that it has to do with cost reduction. Planning and scheduling, when you have significant gaps in your planning and scheduling processes at your work site, you may realize it, but your company is facing higher risks, safety risks, equipment failure risks, and of course the costs are going to be way higher when you're not good at planning and scheduling. And getting good at it is on this next slide, just real briefly. It says that the Penn State Applied Research Laboratory said years ago in this study that they did, that everybody quotes, that the North American industries, we could recover between $200 and $500 billion every year through improved physical asset management. It's just an enormous amount of money that's being left on the table, and these savings, everyone's gone through Lean Six Sigma type of improvements, and they rode those waves of improvements in the 90s and in the earlier part of this century. And now people say that reliability improvements, that's one of the last big multi-million-dollar savings that's left in industry, and a lot of it is low-hanging fruit. And of course, as you can see on the slide, the benefits are just so enormous. The case for getting good at planning and scheduling is because it will really accelerate how you are going to achieve reliability and cost reduction targets at your sites. The manufacturing costs, when you look at them, you say, how much are we spending on maintenance? Many times you see that's greater than the gross profit that you're getting. And you look at the number of losses that are incurred that we can't make product, or we're not making it to spec, or we have so much waste and scrap and downtime. These are serious things that if we get good at planning and scheduling and we're successful there and we can improve our wrench time, that means that in large organizations, there are literally thousands of man hours that you're currently spending for people to look for parts and look for drawings and to have the work that's not been planned and coordinated out with production. There are literally thousands of man-hours that you need to harvest from these non-value-added activities, and that gives your workforce time to go to all the meetings that it's going to take to make improvements in reliability, whether you're doing that through a RCM implementation or a classic TPM implementation or whatever hybrid type of an improvement approach you have there. But this is the main thing that your company has to know is you've got to get really good at this piece. And look, this slide says if your percent productive work is low, your wrench time, let's say, and you have $1 million maintenance budget, with a low percent of wrench time, you're spending more of your $1 million budget on non-productive work, which is paying workers to wait for the next job and to go over and stand by a machine that's not ready to be worked on and to go and spend an afternoon looking for the parts that they need and then going home early in the day than they should, et cetera. And very little of your money is being spent on wrench time. And if you can improve that number percent from 30% to 50%, let's say, then not only is more of your money being spent on value-added activities, but that money represents thousands of man-hours that were being spent when they didn't need to be spent in these non-value-added activities. Because it's efficiency and effectiveness that is what is needed to achieve reliability. Getting the jobs done, a lot of companies have such a high maintenance backlog, and they can't shift from a reactive organization to a proactive one because they're spending so many non-value-added activities because they're not good at planning and scheduling. And there's reasons why, wrench time might be low and we're not using the maximum number of our hours the way we should be. Sometimes it's the PM program itself. If it has not been well thought out, if the procedures are just check the bearing, check the this, check the that, but there's no details and no QA specs, and if no one's thought through the periodicities and gone through an analysis that says that no, this shouldn't be done quarterly, we need to do this annually and save all these man hours. The other things that you can see on the slide about robbing us is when we have so many emergencies hitting us in the face, we can't work on planned and scheduled work. In fact, we don't really have time to work on planned and scheduled work. This is our classic, this slide here, just when I ask the students when we teach planning and scheduling classes to give me their, to try to put it in one sentence, what is planning and scheduling all about? And sometimes I have them write down their sentences, and you get various responses. But one of my favorite ways of trying to put it in one sentence is this one, is that planning and scheduling is about getting more work safely done within a certain period of time. So that could be during an outage or during a PM window when a production line goes down for 8 hours, and you can go in there and get a lot of needed work done. Or it could be during a work week, Monday through Friday. How much work did we get done this week? How many work orders did we clear out of the system, all that? So that's what it's about, is getting more work safely done. So at the heart of it all is safety and efficiency and effectiveness. And we tell in our planning and scheduling classes, because a lot of times we have supervisors in there and planners and people from all over the workforce that are in these planning and scheduling classes, because they all do need to hear a common message about this. And we talk about how do we get more work safely done within a period of time. That has to do with the way we go about applying lean management principles, such as the elimination of waste, to maintenance work. And you can see the types of maintenance waste and losses that we classically see when we go and do an assessment of a company's potential for improvement, let's say, and give them an understanding from our point of view of what they're doing good and what they're not doing so well and where their improvements are. It's an opportunity analysis. And we go look around, we go to so many different maintenance groups, and we see some of the things that's impacting their wrench time being low, because the wrench time in some cases is low as it's less than 20%. But what we see is there's a lot of repetitive repairs that have been going on, and there's a number of root causes why. And there's a fair amount of rework that's done, whether a contractor does a job and then we have to go and redo that job, the next day or the next week, or, we rebuilt this pump and, gee, it's already crapping out, 2 weeks later. There's a lot of unnecessary maintenance because the PM programs have not been optimized, that's for sure. And then there's these things that you see in the bulleted list here, all the looking and the time that it takes to go find the parts and the tools and the drawings and the diagrams that you need because they're not available, they've not been organized. There's a lot of travel time and waiting time because things haven't been properly coordinated and scheduled. Even things like just troubleshooting the equipment. A work request comes in that says we're having a problem over here with this machine, and it was reported, 3 weeks ago. I don't see any progress on. Has anybody even gone and looked at it and estimated what it's going to take to fix it and ordered any parts? There's just all this time that's built into the system because we're not using the CMMS system properly sometimes. I skipped over a slide. Let me go back one. This one is 5 reasons to plan the work, and they're pretty obvious. If you want to eliminate the uncertainty that some people may have when you're telling them that because if the work order only says to go refurbish machine X, well, that could mean a number of things, perhaps. So do you want us to replace this? Does that include this? They may not know the start and the end point of the whole job. Number 2 is increasing efficiency and effectiveness and safety. So that's the heart. That's the reason why we plan for the most. That's the main heart of it all. The third thing is getting a better understanding of a job, like especially these big jobs that are on a critical path, on an outage, where you really need to know that, how many people are going to work on that job for how many days in a row, and how does the work has to be synchronized together, and what are all the potential things that could happen, and how do we put a contingency plan in place for these types of delays that we anticipate. That's number 3. Number 4 on our little chart here is it says you have to plan the job out first and get an estimate of the number of man hours it takes to do the job before you can ever put a schedule together. Your schedule would be completely non-workable and non-achievable because there's no man hours. So you just wouldn't be able to do it. And the 5th one is to enable improvement. So every time a job is done, especially if it's a PM job, every time a PM work order is given out, someone goes and does a PM, we better learn from that PM and get some information back from the craftsman that says, okay, here's what we did on the PM, here's what we found, this PM needs to be changed in one way or another, etc. And we need to learn from it, not just accept these PM programs as if they were handed down from our organizational ancestors that we have to follow, religiously. They have to be improved. Anyway, so here's the other thing about planning I just want to say is planning is not synonymous with the word intending. And you hear that sometimes. People say, oh, well, we're planning, here's the things we're planning to do on our next production down day. And so they're planning to do these 8 jobs. But then I say, well, let me see the plan. And, let me look at the work order. And there it's maybe insufficient, because they've intended to do these jobs, but the planning means you go through it, and it's more than about what's written on the work order. It's about all that prep work that needs to get done, the parts that have to be QA'd in advance and put together in a parts kit and taken over, to this department, let's say, and put in a laydown area and all that kind of stuff. It's not just thinking through the steps of a job, but, in our planning classes, sometimes there's brand new planners in there. And sometimes there's supervisors in there that have never been through a planning class, and we need to, and we go through this in a lot more detail than I'm going to go through on this webinar today, but here are the 5 fundamental planning tasks that are important and that we talk about. One is the scope of work, to actually take time to go out on the floor and look at that work order or work request and vet it and talk to the people who wrote that work request and go and look at the scene yourself and see what's going to be involved and look for unique potential safety aspects of the job, like if scaffolding would be so high and that would impact overhead live wires would be important to know. Or if they're fixing a valve, well, do they need the valve replacement kit, or is it just as simple as just tightening up the packing, or et cetera. And so, yes, number 3 is pretty intuitive that planning involves identifying out the key tasks. So it could be to rebuild a piece of equipment, but there's 7 key tasks that are involved in that rebuild. And those 7 key tasks, each one, there's a number of very important steps have to be followed. And you don't want to go into too much detail or you'd be writing a huge procedure that's not needed. But there is a certain level of detail that's absolutely required for standard work to be achieved and everyone to do things in a uniform manner. The fourth thing is to identify, how many electricians and hydraulic skills and special tools and equipment, materials and parts, and get all that all detailed on the work order so that you know what to prepare, what to kit, what, solvents are required, all that. And number 6 is to get all that together, QA it in advance, get everything kitted and staged to really achieve a high efficiency workforce. And then, of course, it's the other information that the craftsman might need. The BOMs, the bill of materials, will be very critical if they take a machine apart and then they realize, uh-oh, this thing here is broken. Well, if they have a bill of materials, then they know exactly where to go in the warehouse and to get them and the part number and what shelf it's on maybe. The QA/QC requirements, these are the specs that are, you have to go from the subjective inspection to a very quantitative one and write down the torque specs and write down which particular type of grease is required in this application and how much grease. I mean, you have to be specific or variation will follow and people will do things different ways and you've lost the prize of reliability at that point. The last 3 on our little list here is estimating the job out and how many folks that you're going to need to do it. Number 10 is important, is to give the work orders out this week to the people that are going to do them next week and give them an hour to read the work orders over and look at the work that's going to be done next week. And they should be part of putting that plan together. They should be part of, because they have a lot of good ideas about what needs to be done to get these jobs ready to go. And so we need to get feedback from the doers in advance if we can. And then, of course, number 11, like I said before, we have to improve every single time that we put a plan together and then that the craftsmen go and do it. And that when they turn it back in, we check to see how accurate our plan was. Was our man-hour estimate correct? Did we have the right parts and tools? Did the workers have everything they needed to be efficient? That kind of stuff. I want to tell you another thing that impacts planning, though, is this. We walk through plants sometimes and you'll see all these types of things as problems on the production floor that you see listed here. And that's because people on the floor are not reporting these things in. They're not using the work request system. And so in some cases, we have them use tags when we're implementing operator care program. But when they don't report all these things to the maintenance group, and these could be people in production and maintenance are both walking by and they see problems, but maybe they just hate the work request system. I just don't like putting them in, and no one really cares. This stuff has been, we see information or problems like this on the shop floor that's been there for weeks and weeks and weeks. But employees just walk past it a lot of times. But that stuff represents the hidden backlog, and those are the unidentified defects that haven't been put in the CMMS yet. But you're going to have to do them, and they're going to get worse and worse as you go on. A lot of planners have been trained about the PF curve and how if we wait too late to identify maintenance problems, the cost and the impact is so high, and how these unidentified things are going to really impact our reliability and our ability to plan. Because if you're a planner and you're turning the PDCA wheel in the middle of this diagram, and yet all these failure modes are allowed to flourish out there because people are not keeping their equipment clean, or they're allowing dirt and contaminants to get in, or I've been in places before where the roof is so leaking on top of a compressor and the oil system is just degraded with water that's coming in, as well as pigeon droppings. But if you allow all these failure modes to come in, you'll never be able to plan fast enough to get enough work done. You've got to, part of planning is making sure that the inspection program and the people are using that work request system and get that information into the planner as soon as possible. They're walking around these problems and they just assume other people know about them, or that somebody else's responsibility, or they don't have time to do it. The other thing, and this is the last 2 slides here, and then we'll have to get off this webinar, but it's important, I wanted to say this to folks, a lot of times planners need to, and planning teams need to apply SMED, which stands for Single Minute Exchange of Dies. And they need to apply SMED principles to planning and scheduling, because oftentimes we apply SMED principles to changeover improvements. And as you can see on the chart here, that you can take, by planning and scheduling it properly, you can take any one of these tasks and look at the before column and see how long that task took. And then after they applied these principles, what a huge reduction in the time that there has been. Well, that's one of the goals of planning and scheduling, is to reduce the time that it takes for us to do a bunch of maintenance interventions that are very similar to a changeover. And as the pie chart shows, most of the improvements come through better organization and planning of the job. Very little come from, special tools or special equipment, but there's so much impact that we can make if we applied SMED-type principles and we moved these INT, the green INT, internal activities, and changed as many of those to external, which means we do those before the maintenance event, before the down day comes along. This is our prep work that we have done that's going to reduce the overall time of the maintenance scenario, because we're organized. And the slide here shows you who's going to do better, either on the left, which is that cabinet that's so messy, and maintenance people, if they suddenly needed a part, and they would go over there and spend a lot of time looking for what they're looking for. Otherwise, you've got on the right side of the slide all of the good applications of SMED principles, where on a production unit line down that goes down, let's say annual, for an annual PM on a production line, they can wheel out these carts, and it's got everything that the maintenance team needs to do that rebuild right there, all the consumables, all the supplies. The overall maintenance timeline is visually formatted and put up on the wall. These are just common applications of visual management and SMED that we should apply to planning. Here's our last slide, and it's just to review real quickly. I believe, number one, starting in the green, that the estimates are needed. Time estimates are needed for these jobs for you to have a backlog, because a backlog is supposed to be judged in terms of the man hours, not just the number of work orders in the backlog. Your level of planning is going to vary. You have to use your time wisely, because some work orders come in that you really don't need to plan very much. And there's some of them, but you could plan it and you could put in too much detail. So it's a judgment call based upon the complexity of the job and what your people really need to do that job efficiently and effectively. The third thing is to always remember that the goal, what's the goal is always about is wrench time and getting more jobs safely done in a period of time. And to talk about that, every time you have a planning and scheduling meeting, how are we doing with wrench time? What's getting in our way? What are our plans to make improvements? Because you want to use the next two things on this wheel here, PDCA, to drive improvements with your action plans for planning and scheduling. Every one of these organizations needs to have a planning and scheduling action plan that's in support of their goals. So that's one thing, PDCA. And the second thing is SDCA. How good are you at using standards? S is standards, and then D, they implement to these standards. We check every so often and we take action. But how good are you at using maintenance planning and scheduling standard practices to drive variation out of the whole process? And then at the top, make sure that the craftsmen know how important their information is to tell us how that job went, because they know a lot about these jobs, and they have a lot of real good information they need to give us on these work orders so we can improve as we go forward. But that, we don't have time to talk about a lot, but those were some of the key things that we wanted to share with you today about the planning aspect of planning and scheduling.